Hello and welcome to my video demo for my HALT program. I've created this by myself. My name's Lachlan Smith. I'm part of Gold Coast Group 5 for Programming and Robotics. HALT is basically a little study assistant that is meant to be put on a desk to help people take breaks when they're studying and promote healthy behavior and keep people focused on their goals of studying. This would be especially useful for uni students like myself right now. So that's the mindset I've gone into creating this. So in this program, we can see that we've started it. We've implemented keys being P, O, 1, 2, 3, E, and R. The 1, 2, 3 are supposed to simulate claps that would be used to talk to the robot. And we start in an idle position. So if we start up the program again, we can see that we'll be able to detect a red block. So then it enters into a monitoring mode, which we can see in the FSM here. So then the next step is a gentle reminder. So if we wait a bit, we'll start to see that we start to get a little gentle wave from our robot. These times are significantly reduced just for the demo. So we can see that that's happened there. If we wait a little bit longer, we'll get escalated into a bigger wave like that. And we can see if we click 1, we'll go back into gentle reminder, 1 again, and we'll go back into monitoring. So 1's supposed to be snooze, basically going back 1 step, when it's just like, yeah, go on, it's all good. So if we're gonna wait again for this to escalate all the way up, and then we're going to acknowledge it. So acknowledge basically is resetting the whole cycle and implementing new times, which is our AI behavior in the background, which adjusts the times and thresholds of stuff based on, hey, did they go to escalated and only accept it in escalated, or were they in gentle reminder, and acknowledging it then basically saying they don't need to be escalated so quickly. So we could see that when we when we acknowledge, we get the thresholds updated and we go back into monitoring. At any time, we have the failsafe option, just by clicking E. So that simulates failsafe with any sensor fault. We also have the reset and we have quiet mode. So this is basically it turned off and nothing can be done here. We can just wait for the timer to run out there. That's basically the program. Once we move this red block away while it's in monitoring, it will detect, hey, there's nothing in here, so it goes back to an idle state. And then in the code, the way I've implemented the code is using a main folder and then splitting sense, think, and act all into separate programs to help kind of manage my different servers and stuff that I've used. Also, as well as config to just get rid of some of the numbers from all the mains, like the thresholds, the motor stuff, and all the states that we use. So in Sense, we use a red detector using camera top. So all this does is detecting the ratio of pixels on a screen to say, hey, is there red on the screen? And then in here, it updates it to say, hey, you can go into a monitoring state now. We go to think, and think is handling all the adaptive behavior in this section here, handles the keyboard presses, and updates basically all the states that it's in. So it's pretty much telling the system, hey, you're in this state, hey, you're in this state, and then this is when act comes in. So act will then change the position of the robot, which gave us the waving, the hands to your face, the escalated waving, and the idle pose. So this is all set up here, and it's really easy because I set the max and the min and max stuff for the NAO system in here, and then it all comes back to this simple loop right here of going to handle keyboard, update presence, update FSM, and it's just running this over and over again. That's my demo for this video. Thank you for watching.